This video demonstrates how to sort an array of numeric keys in ascending order using the merge sort algorithm. Merge sort recursively divides the array into smaller subarrays, sorting each one, and then merging them to form the final sorted result. Suppose we already have two sorted subarrays. The first subarray consists of 2, 3, 4, and 6, while the second subarray contains 0, 1, 7, and 8. These subarrays occupy contiguous sections of a larger array A, from indices 9 to 16. We'll refer to the left subarray as L and the right subarray as R. The process of merging L and R replaces the corresponding elements in A in sorted order. To achieve this outcome, we use three integer variables, I, J, and K. Here, I tracks the position in A where the next smallest value will be placed, while J and K identify the current positions in L and R, respectively. Initially, I points to index 9 in A, while J and K both start at 1, corresponding to the values 2 in L and 0 in R. We begin by comparing these two values. Since 0 is smaller than 2, we place 0 at index I in A, and then increment both I and K. Now K points to the next value in R, which is 1. Next, we compare 2 and 1. Since 1 is smaller, it is copied to index I in A, and we again increment I and K. Now K points to the value 7. We continue this process, 2 is compared with 7, and, because 2 is smaller, it is placed at index I, and J shifts to the next element. This pattern of comparing and copying continues until one of the subarrays, L or R, is fully traversed. Once all elements in L have been processed, any remaining elements in R, in this case, 7 and 8, are directly appended to A. The final sorted sequence in A is 0, 1, 2, 3, 4, 6, 7, and 8. This merging procedure, known as merge A, PQR, is fundamental to merge sort. Here, A is the array being sorted, P is the starting index, Q points to the last element in L, and lowercase r to the last element in the array denoted by uppercase R. For this example, the procedure would be denoted as merge A, 9, 12, 16. Merge sort combines this merging step with recursive calls, as illustrated in the pseudocode. A recursive algorithm is one that calls itself. Let's examine the pseudocode before walking through another example. The condition in line 1 ensures that the procedure stops recursion when the subarrays become empty. Otherwise, Q is calculated as the midpoint of P and R, using the floor function to ensure an integer result. Lines 4 and 5 recursively sort the two subarrays, while line 6 merges them. To illustrate, consider an array with the elements 7, 0, 1, and 8. When we call merge sort A, 1, 4, the if condition is not satisfied, so we calculate Q equals 2, and subsequently call merge sort A, 1, 2. Later, we will also have to call merge sort A, 3, 4, and merge A, 1, 2, 4, so let's already take note of these function calls, leaving space for additional calls that may happen along the way. Upon calling merge sort A, 1, 2, Q is set to 1, and merge sort A, 1, 1 is invoked. Since P equals R equals 1, the recursion terminates immediately, returning control to merge sort A, 1, 2. The next step in this context is to call merge sort A, 2, 2, which also terminates because P equals R equals 2. Finally, the merge procedure merges the value 7 and 0 into a sorted subarray. Control then returns to merge sort A, 1, 4, where merge sort A, 3, 4 is called. This call triggers merge sort A, 3, 3, and merge sort A, 4, 4, both of which terminate immediately. The merge step then combines the values 1 and 8 into a sorted subarray. Back in the original call to merge sort A, 1, 4, the final merge step combines the two sorted subarrays into a single sorted array, 0, 1, 7, and 8. To reinforce your understanding, try applying merge sort to a longer array. Work through each recursive call and merging step carefully. Your instructor can provide sample solutions for comparison. Happy learning!